Okay children, let me do the continuation of the same application, electric field due to thin infinite plane sheet of charge. Okay, so I was explaining the field which is produced by this area A where the charge is Q, and this field produced by this area can produce on both the sides of the thin sheet. Okay, so one is at P on the right hand side, another is as P dash on the left hand side. But remember this, the field produced by positive charge is always directed away from the charge. That means field produced by this charge is this side also. It can produce this side also. Okay, so if to calculate the field at P and P dash, I can draw this similar size of area, that means A. So this, if this area is A, then this whole area is also A. Then this area is also A, and I take this point P and P dash at the same distance, that is R and R on both sides from the given area. So the field which is produced by this much area is also on the same direction, also produced on both the side, and that means this field produced by this area on both sides will be on in this much area also, that is at P and what P dash. So taking this P and P dash and having cross section area A on both the sides, we can draw the surface, and this surface is called cylindrical Gaussian surface. So just join the line of this point of area. Okay, then you can see there is a surface which is formed. This is known as cylindrical Gaussian surface, and every cylindrical Gaussian surface has two cross section area. These are the cross section area, and this cross section area is equal to the area of circle and has curved surface. These are the curved surface of the cylinder. So we calculate the field on the entire cylindrical Gaussian surface. Okay, on the entire cylindrical Gaussian surface. So for that, first of all, we calculate the field due to this area of charge Q at point P and P dash, that is at two ends of the cylindrical Gaussian surface. So for that, I'll take a small area element at this point, that is small area element of the entire area, and that entire area is also what? A. So what is the entire area of this surface cross section area? That is A, same area as this. Okay, so if there is a small area element of this entire surface area, then this area vector is also directed outward normal. So at the same point, the field is also directed outward away from the point. That means you can see in the diagram at the point P, electric field and area vector are in the same direction. If they are in the same direction, means what is the angle between them? Theta equals to 0 degree. The same thing happens for another point P dash. So at this point P dash also, if I take a small area element, then area vector directed outward normal. So at the same point, the field is also directed this side. So what is the angle between them? 0 degrees. So outer angle is also how much degree? 0 degree. So that means at both ends of the cylindrical Gaussian surface, your area vector and electric field are in the what direction? Same direction. So now we calculate the electric flux at the two ends of the plane end of the cylindrical Gaussian surface, and that flux is measured by this relation. That means the electric flux through two plane end of the cylindrical Gaussian surface is given by phi E, and that flux equals to integration of closed surface of area A, E dot dA. This is for one closed surface, say this P dash P, plus integration closed surface of area E dot dA for another closed surface, another plane surface. That means this field is for flux is for this surface, and this flux is for this surface. So if I add the total two flux, that gives the total flux, the electric flux for both the surface. But you know the formula, E dot dA means E dA what theta cos theta, plus this is also E dA what theta cos theta. Now in this expression, let me tell you, you take the entire surface cross section area, the field, the magnitude of field will be in the same direction and have same magnitude. That means this field is constant in magnitude on both the surface. So what I do, I just take out from the integration. If I take out from the integration, so it will be how much? This E is constant, but you know what is the angle between E and dA? 0 degree, so cos 0 degree, and this is also cos 0 degree. Now you see, E dA cos 0 degree is 1, plus integration of closed surface of A, E dA into 1. So E, as I said already, is constant. So I just take out integration out from the integration. So integration, so electric flux equals to E integration of dA plus E. This is also constant, integration of dA. Now E integration of dA equals to A, plus E integration of dA is also what? A. So EA plus EA means 2EA. So the flux, electric flux is given by 2EA. So this is for the two plane surface or cross section area of the what cylinder. So the remaining part of this I'll explain in the next video.